Welcome to the discussion on key energy facts. I'm your host, Tushar. I have over 25 years of experience in the energy field. This includes technology development and evaluation in a wide range of energy areas. For information about my patents, books, papers, awards, and honors, please visit my website. A rapid energy transition is a shift to low carbon energy by the middle of this century. Such a shift has been strongly recommended to meet the goals of the Paris Climate Agreement. For a realistic discussion about this topic, it is crucial to consider the major obstacles. In the previous episodes, I have discussed three key obstacles to a rapid energy transition: timely access to critical minerals, timely access to land resources, and global energy security concerns. In this episode, we'll review two more key obstacles: technology gaps and shortage of skilled workforce. I'll start with the discussion on technology gaps. The energy transition involves a massive shift to new technologies. For a massive shift, the new technologies must be available for a wide global use. What does it mean to be available for a wide use? It means that the new technology must at least have a comparable performance and cost to the technology it is replacing. In other words, the new technology must not have major performance or convenience issues, and it must not be substantially more expensive. Access to quality data about the new technology is critical to avoid being misinformed about its true potential. Such access is only possible after a technology has been in substantial use for several years. Why? Because it takes many years to understand the long-term performance of a new technology. To be acceptable for wide use, a new technology must demonstrate robust long-term performance at different locations and a wide range of operating conditions. Such data is only accessible after the new technology has achieved a substantial market share. Thus, a new technology is truly available for the energy transition if it has satisfied two criteria. One, it must have a substantial global market share. And two, it must have a comparable performance and cost to the technology it is replacing. A technology is practical or available for wide use only if it meets these crucial requirements. Unfortunately, these crucial requirements are often ignored in proposals for a rapid energy transition. Why is this important? Because the new technologies required for many applications do not satisfy these basic criteria. According to the International Energy Agency, the technologies that will be required to reduce about 35% of the CO2 emissions are yet in the demonstration or prototype stages. These technologies are yet far from being available for wide global use. We'll review the key technology gaps in the power, transportation, and industry sectors. Most of the proposed energy transition pathways include a very large share of solar and wind power. Long-duration energy storage technologies are crucial to ensure high reliability at large global shares of solar and wind power. Such technologies are designed to store energy from days to weeks. Examples of technologies that are being considered for this purpose are novel battery systems and low-carbon hydrogen. But these technologies are not yet available because they are far from competitive. Ships and aircraft are significant emitters of greenhouse gases. They must carry heavy loads and travel long distances. Liquid fossil fuels have a major advantage for these applications. This is because of their high energy densities and reasonable costs. The proposed alternatives such as batteries, hydrogen, and biofuels have practical limitations and high costs. Consequently, these technologies are still in the demonstration or prototype stages. Several key industrial processes require high temperatures. Examples are cement and metals production. Fossil fuels are used for such processes presently. Alternative low-carbon technologies in this space are still in the demonstration stage. These low-carbon technologies that we have discussed earlier have far more challenges than solar power, wind power, and electric cars. That is why they are still in the demonstration or prototype stages. We'll denote these as difficult technologies. So what does history tell us about the time required for a new energy technology to move from a prototype stage to a 1% market share? For wind power, it took over 30 years. For solar power, it took over 50 years. And it took over 30 years for lithium battery use in electric vehicles. Many of the difficult technologies have only been in the prototype or demonstration stages for about a decade. How much time will be required for these technologies to reach a wide-scale use? No one can accurately predict this, but we can guess based on historical data. The easier technologies such as solar and wind power have taken between 30 to 60 years to reach a small fraction of the market share. Therefore, most of the difficult technologies are likely to take several decades to have a major share of the market. This is a major obstacle to a rapid energy transition. Let us review the obstacle related to skilled workers next. A massive increase in deployment of clean energy technologies will be required for a rapid energy transition. This means that many millions of additional skilled workers will be required. According to the International Energy Agency, clean energy jobs will need to increase by 17 million from 2022 to 2030 to ensure a rapid energy transition. Many of these jobs will require workers with skills specific to the clean energy industry. Why is this a major obstacle? Because the shortage of skilled workers is already a problem. China is struggling to fill positions in its factories. Its Ministry of Education has predicted a huge talent gap in the coming years. Europe and United States have a shortage of pipe fitters, electricians, heating technicians, and construction workers. Such shortages are already restricting the pace of the transition. There is no easy and quick fix to this problem. Training a massive workforce to develop special skills is challenging and takes time. How do we know this? Because the shortage of skilled workers in the clean energy area has been rising since the past several years. The desired improvement is not seen. To make matters worse, the deployment of clean energy technologies will need to greatly ramp up over the next several years. Such a rapid ramp up will not be possible if there is a shortage of skilled workers, which is likely to be the case. Let us review the highlights. A substantial fraction of technologies required for the energy transition are not available for wide use. In fact, several technologies in key areas are still in the demonstration or prototype stages. Historical data indicates that several decades will be required for these technologies to achieve a large market share. So technology gaps are a major obstacle to a rapid energy transition. There is shortage of skilled workers in the clean energy area in many countries. The gap between the required skilled workers and available clean energy jobs has been widening. The situation is only expected to get worse. This is because the energy transition proposals require a very large increase in the deployment of low carbon technologies in the coming years. So shortage of skilled workers represents a major obstacle to a rapid energy transition. See you soon with another episode about key energy facts.